Okay, this is the second video for section 2 in your McGraw Hill Geometry textbook. This will complete the section. We've got a vocab word to cover, and then we'll talk about the distance and midpoint formulas, both of which you should be familiar with from algebra. So, our vocab word here is this idea of congruent segments, which would be two or more line segments which have the same length. So here in the picture you see two line segments AB and CD, each of which has a length of 1.7 centimeters. Since they are each 1.7 centimeters, we are able to say that AB is congruent to CD because the length of AB is equal to the length of CD. So congruent segments, two or more line segments which have the same length. Alright, so that means we have to be able to find length on the coordinate plane. So while we're at it, we are actually going to not only do distance, but we'll also talk about midpoint. Okay? So it says find the distance between A, which is located at 3, 7, and B, which is located at -2, -5. Okay, so to do that, we are going to use what is called the distance formula. The distance formula is on the I-Step 10 reference sheet. It is also, I believe, on the reference sheet for the SAT, ACT, the one that's given on the actual test. And it is the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Now keep in mind, these are the same. x1 is 3, y1 is 7, just like slope formula from algebra. x2 is -2, and y2 is -5. So it's these same approach we would take if we were finding the slope of the line through those 2 points. So we plug those numbers in. So the distance is the square root of x2, which is -2, minus x1, which is 3, quantity squared, plus y2, which is -5, minus y1, which is 7, quantity squared. Now be careful with the negatives. That is the place where most people make mistakes. If you're very good, you can type that directly into a calculator, but I'm not that good, so we're going to write out a little bit more. -2 minus 3 is -5, and -5 minus 7 is -12. When I square -5, make sure you're putting parentheses around that in your calculator. You should get 25. When you square -12, you should get positive 144, because a negative times a negative, or negative times itself, is a positive. That would be the square root of 169, or 13 units. Now, alternatively, and this is going to take me a second to do because I don't have it ready to go, if we wanted to, we could do the same thing with Pythagorean theorem. And here's what I'm going to show you that just so you can see it. Okay? Let's keep in mind that A at 3, 7 and B at -2, -5 are locations, which means that I could connect them with a line segment, like that. Well, the same way that I can connect those 2 points with a line segment, I could also drop a vertical line straight down from A, and a horizontal line straight across from B, which would form a right triangle. Now once I have that right triangle, I can simply count the lengths of the legs. From B to the corner, is 5 units, and from A to the corner is 12 units, which means according to Pythagorean theorem, which is a squared plus b squared equals c squared, I can state that 12 squared plus 5 squared is c squared, which again, I've done that already over on the other side. It's the same exact thing. Would give me 13 units for that length. I want you to use the distance formula. You have all been through Algebra 2. You shouldn't need to graph the points to find the distance. But if you were given a test item on the coordinate plane, you could potentially take a slightly faster path using Pythagorean theorem. Now, while we're on the subject of things we should already know from algebra, the other thing would be the midpoint of AB. So the midpoint formula says that the midpoint M is located at the average of the x-coordinates, so x1 plus x2 divided by 2, and the average of the y-coordinates, y1 plus y2 divided by 2. These are the same x1 and y1 as the previous example because it's still the same 2 points, A and B. So what I like to do is I like to write it out as 2 separate equations. I start with the x-coordinate, which would be x1 plus x2 divided by 2. That would be 3 plus negative 2 divided by 2, or 1/2. The y-coordinate, same idea. We do y1 plus y2 divided by 2, which is 7 plus negative 5 divided by 2, which is 2 divided by 2, or 1. So the midpoint, M, is located at the point 1/2, 1. Let's do another example of distance and midpoint. Just one more example for the record. And here it is. Find each of the following if A is located at 4, 2 and B is located at negative 3, 6. So notice that it doesn't say the length of AB or the distance between A and B. It just says notation AB, which means the length of segment AB, right? Or the distance. So, x1, y1, x2, y2 are given in the problem. The distance formula says that AB is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So that would be negative 3 minus 4 quantity squared plus 6 minus 2 quantity squared. That would be negative 7 quantity squared plus 4 quantity squared. Negative 7 squared is 49. 4 squared is 16. Which means we're looking at the square root of 65. This is another place where algebra comes into play. In theory, we should check to see if root 65 will reduce. It will not. So we would either say root 65 units, which would be an exact answer, or approximately 8.06, which is the decimal approximation to the nearest hundredth, units. I really would prefer the exact answer, but I would accept a decimal approximation as long as it is accurate to the nearest hundredth. And the only way you get that is if you do not round until the problem is over. Second part says find the coordinates of the midpoint of AB. Again, our midpoint formula says that the midpoint is located at the average of the x-coordinates and the average of the y-coordinates. So even though it's written like this is two separate equations. We start with the x-coordinate, which would be x1 plus x2 divided by 2, which would be 4 plus negative 3 over 2, or 1/2. It's a coincidence that we got the same x-coordinate as the last problem. And the y-coordinate would be y1 plus y2 divided by 2, or 2 plus 6 divided by 2, which is 8 divided by 2, or 4. So we have an x-coordinate and a y-coordinate. That makes a point. Our midpoint is located at 1/2, 4. That does it for the notes for section 2 of your McGraw Hill Geometry textbook.